Jatra. My name is Vanish. My matric number is B11241021. So I will explain about our project. So we have done a project. The name is Smart Safety Box with hazard detection. So I will explain about introduction. So what is Smart Safety Box with hazard detection? The Smart Safety Box with hazard detection project is designed to provide a comprehensive solution for the monitoring and responding to hazardous environmental conditions such as high gas levels and extreme temperatures. The system uses on Arduino Uno as the control central, connected to sensor like the MQ2 gas sensor for detecting harmful gases and LM35 temperature sensors for temperature measurement. When dangerous conditions are detected, the system activates alerts through an audible buzzer, a visual LED, and a servo motor to stimulate the unlocking of a safety box. A manual emergency button is also included, allowing immediate activation of the alert system for added security. This project aims to enhance safety by providing real-time monitoring and a quick response to potentially hazardous situations.
Assalamualaikum warahmatullahi wabarakatuh. My name is Zafran Faizuddin bin Aziz. My matric number B11231058. Okay, my part is system operation. The Smart Safety Box with hazard detection is a microcontroller-based system designed to store items safe by detecting dangers like high temperature or gas leak. It's useful in places like a lab, workshop, or home where sensitive material are kept. When turned on, the system sets up all its components: a gas sensor and Q2, a temperature sensor, a push button for emergency, an LED, a buzzer, and a servo motor to lock or unlock the box. We constantly read data from the sensor and show the value on the serial monitor for monitoring. And how it works: the emergency button is pressed, the system immediately turns on the buzzer and LED, lock the box, and show warning messages. This gives user a way to quickly activate the system manually. If the system isn't pressed, the system check for hazard if the temperature is above 50 degrees Celsius or the gas level is too high, above 100. It also lock the box, turn on the buzzer and LED, and warn the user. If no danger is detected, the system keeps everything normal, the box stays unlocked, and the alarms are off. The system keeps running in a loop, always checking for danger and responding right away. In summary, this smart safety box protects items by automatically detecting hazard and locking the box, while also allowing manual emergency activation. Okay, for the flow chart of the system, we should know function of the shape. Uh, all flow chart ni. First is diamond is decision. If rectangular is input or output, and rectangular signet ni adalah process. Okay, first is system start. Temperature conversion. The analog temperature data is converted to Celsius for accurate analysis. After that, data display. The system print temperature and gas level to the serial monitor for reading. Emergency button check. If the button is pressed, the system turn on the buzzer and LED. Move the servo motor from 0° to 90° to lock the box. Display emergency message, emergency button on, and the box is locked. After that is hazard detection. If no button is pressed, the system check if this is for decision. Eh, this button is for decision. This is for loop hazard detection. If no button is pressed, the system check if the temperature higher than 50 degrees Celsius or gas level higher than 152, it activates buzzer LED and lock the box. If all false, it keep the LED and buzzer off and unlock the box. It will loop continuation. The system loop back to the start to read sensor value continuously, ensuring ongoing monitoring.
Hello, Assalamualaikum, and hi everyone. My name is Zulharis, and I will present the circuit diagram part for our embedded system assignment. So, this is our circuit diagram for our embedded system assignment. So, we create this circuit using Proteus 8 Professional software, which allow us to simulate the project before using the real components. The main components in the circuits are Arduino Uno as the main microcontroller, MQ2 gas sensor to detect gas or smoke, LM35 temperature sensor to measure temperature, red LED and buzzer as alert indicators, a servo motor to lock and unlock the box, a push button for manual emergency input, and a virtual terminal to show system status through serial monitor output. So, all the components are connected to Arduino according to the code. The MQ2 sensor is connected to A2, the LM35 sensor is connected to A0, the buzzer is on pin D2, the servo on D3, and the LED on D4. This emergency button is connected to D8, and lastly the virtual terminal is connected to the TX pin to display output message. All components use 5 volt and ground for power supply. Circuit function and behavior. The Arduino reads data from the temperature and gas sensors. If the temperature is above 50 Celsius or gas level is more than 100, the LED and buzzer will turn on. The servo motor rotates to 180 degrees, which means the box is unlocked, and the message warning danger is shown in the serial monitor. If the push button is pressed, the system reacts the same way. It turns on the alerts and unlocks the box. Once the values go back to normal, the LED and buzzer turn off, and the servo rotates back to 0 degrees, which is in lock position, and the message box is safe to unlock is display. That's all from me for the circuit diagram part. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Hazid Azhad bin Azman. Today my part is going to explain about the test program. Okay, if you look at the first line, we start with include the servo file to the Arduino IDE. Then we need to clarify the pin of the component that we use, such as gas sensor, LM35, button, buzzer, LED and servo. Okay, next, if you look at the constant integer, we set the gas threshold is limit at 500, and for temperature threshold is limit at 50. Okay, we also declare servo as my servo. Okay, next for void setup, we start with serial begin 9600 for hardware debugging, and we need to clarify the pin, the pin input and output. So for input we use gas sensor, LM35 and push button. Then for output we use buzzer, LED and servo. We move on to void loop. If you look, first we we verify the integer gas sensor value to read the gas sensor value or the gas level. So serial print function is to print the sentence for the virtual terminal. Then we use if gas sensor value greater than gas threshold, so the buzzer pin will hide, then the buzzer will on for 0.5 second and have a delay of 0.2 second. For else, digital write, buzzer pin low and delay for 0.5 second. Next, we use integer for LM35 or temperature sensor. So at integer, LM35 analog value is equal to analog write LM35 pin. So we convert the voltage from the LM35 to the temperature. So if you look at the code, float voltage equal to LM35 analog value times by 5.4 over 1024. Then float temperature temperature equal to voltage over 0.01. Then serial terminal will print serial temperature and the value of the temperature. Next is if temperature is greater than temperature threshold, which is 50 degree, the LED will turn on or hide, then have a delay of 0.5 second. As digital write, LED pin low, which means the LED is turned off when the temperature is less than 50 degrees Celsius, then have a delay of 0.5.
Very good evening to my respected lecturer. Today I'll be explaining about the circuit simulation which is done by using Proteus software. This project is a safety system. The name of our project is a smart safety box with hazard detection. For doing this project in the Proteus, we used an Arduino Uno and an LM35 temperature sensor, MQ2 gas sensor, and an LED buzzer, servo motor, and a push button. It is designed to detect high temperature or gas levels and responds by triggering alerts and unlocking a box. The push button also allows manual emergency activation. The simulation demonstrates how the system reacts in both normal and emergency conditions. Let's look into the simulation, which begins with an initial condition before the system is activated. In the stage 1, the Arduino is powered on and all components such as LM35 sensor, MQ2 gas sensor, and an LED buzzer, servo motor, and push button are placed in but inactive. The virtual terminal and the circuit are idle, indicating that the system has not yet started monitoring environment conditions or responding to any input. This setup ensures that all the devices are ready to operation and confirms the correct wiring and connections. So by doing this, we are allowed to start the simulation. After running the simulation, when the temperature is below 50 degree and the value is under 100, the system remains in a safe state. The servo motor is positioned at 0 degree, locking the box, while both the LED and buzzer are off. On the virtual terminal, the message indicates normal temperature and gas levels along with the status message box is safe to unlock. Box is safe to unlock. So, by confirming that no danger is present, this demonstrates that the system ability to continuously monitor and maintain the safety under normal conditions. This can keep the box safe. Next, after running the simulation, when the temperature exceeds 50 degree or the gas value rises 100, the system enters a danger state. The servo motor rotates 180 degree, unlocking the box to allow emergency access. At the same time, the LED and the buzzer are activated to provide visual and audible warnings of the hazardous condition. On the virtual terminal, the message display on the current temperature and the gas readings along with the warning message, that means warning danger, to alert the users. This demonstrates system ability to detect unsafe conditions and respond promptly to ensure safety. This can make the safety box to be more safe. For the last part, when the push button is activated regardless of the sensor readings, the system enters emergency mode. The LED and the buzzer are turned on. The servo motor rotates 180 degrees to unlock the box. And the warning message appears that remains such as emergency button on, followed by warning danger on, is displayed on the virtual terminal. This shows the manual override function of the system, allowing user to stimulate a danger condition and trigger all safety response manually, which is particularly useful in undetected emergency situations. Once the danger is over, either the temperature drops below 50 degrees and the gas level falls below 100, or the emergency button is released. The system returns to a safe state. The LED and the buzzer will be turned off, and the servo motor moves back to 0 degrees to unlock the box. And the serial monitor displays the box is safe to unlock. This automatically resets, ensure the system remains reliable and at only stays activate during actual or trigger emergency condition. This can keep the box safely.
So thank you, member. So finally, I will explain about conclusion. So in conclusion, the smart safety box with hazard detection offers an effective and reliable solution for detecting hazardous gas and temperature condition in various environments. By integrating sensors with an Arduino Uno, the system can quickly respond to dangerous situations by triggering audible, visual, and mechanical alerts. The inclusion of a manual emergency button ensures that system can be activated even in the absence of sensor-triggered alerts, providing a critical layer of safety. The project demonstrates the potential of embedded system in enhancing security and preventing accidents, making it a valuable tool for safeguarding both residential and industrial areas from environmental hazards. So that's all from us. Thank you.